Hello everyone, this is the first lesson recording for IM2, January 19th, 2021. The first thing we did was we started by doing a graphing exercise on y is equal to 2x squared plus 4x minus 2. I know some of you had trouble with this on your homework, okay? So what you're going to do is you're going to create a t-chart, then plot the points, and then graph this quadratic function. So how you're going to do is you're going to find your x values and then show all the work here, and then find your y value for that x value, and then find the coordinates. So for example, the x value that you should always start with, the easiest in any quadratic in standard form, is 0. Okay, so you should always start with x is equal to 0 usually. And so then it becomes, you're going into your equation and substituting for x to be 0. And so you're putting it all 0 in your equation. So that's going to be 0 squared times 2, which is 0. 4 times 0 is 0, minus 2. So that just becomes negative 2. So my coordinate is 0, comma, negative 2. Remember, when you're using the coordinate notation, x is the first number, y is the second number. So then I can plot this right here. 0 is the horizontal value, negative 2 is my vertical value, is right there. Then the next easy number you should just try is 1. Okay, so then when you substitute 1 into that equation there, then you get for y to be 4. So it's going to be 1 comma 4 in parentheses. And when you're writing coordinate, you need to have the parentheses. Without the parentheses, that is not a coordinate notation. You could be just talking about two different numbers. You're not referring to the first number being x coordinate and the second number being y coordinate. So that's why the parenthesis is very, very important. And so you put 1 comma 4 right there. Similarly, okay, now I'm thinking, okay, so well, this could go further up, or it could be coming down. So I don't know that, so I'm going to try 2. So when I try 2, the value I get is really high, 14. That's beyond the graph range. Okay, my y-axis only goes up to 5, and it wants to go to positive 14. So it's going to be way up beyond my graph. So that's not going to be helpful for us. So instead, we're going to keep going down where we do have the graph. So we have 1 and 0 works. So I could try negative 1 here and get negative 4 as my final answer. So it's negative 1, negative 4. What about when x is negative 2? Plug that in. Find your value. Negative 2 and negative 2, comma, negative 2 will be the point, and I'll plot it here. I am going to suggest you do show all the work, okay? So, and even I was having problem with making silly mistakes when I was working on the homework with a group of students during study hall. So make sure that you show all your work, and so that you do not make mistake of losing any negative symbols anyway, because that's going to come up with a very different number. And you also need to remember the order of operation. When x is negative 3, y is going to be 4, and so it's going to be negative 3 comma 4, and you plot it here. So these are my 5 points that I figured out the coordinate of and plotted there. And then from here, I need to join these points. Remember, parabola shape is like a ball shape. It's not pointy, it's curved, and in fact, it looks like this when I join. Okay, so that's a parabola. This is opening up like as a ball. We say it's like my arm is opening up, and so, and the vertex is the lowest point. That green dot is my vertex, which happens to have the coordinate of negative 1, negative 4, and the line of axis is the reflection line, a line that I can fold this parabola in half, and that always goes through the vertex. So it's going to have the equation of x is equal to negative 1. Alright, so let me go on to some announcements. Quiz number 1 that you did. Okay, so I had mixed groups. Okay, so I have students who did very, very well. I had students who were very quite lost, but I also had students who lost points because they did not multiply back your final factors using FOIL or the area model that I've clearly indicated. Okay, or some people lost points because you did not show the diamond puzzle for number 2 and number 3. Remember, for number 1 I said I do not require the diamond puzzle because it's a very simple problem when a is equal to 1. However, when a is greater than 1, it's very good idea. You need to do the diamond puzzle if you're using grouping method or area model. And those people who did that, they still did not show. You have an opportunity to meet with me to explain your thinking process to get those points back. You lost whooping 8 points out of 25. That's like 32%. Okay, so you could raise your quiz grade up by 32% just by having a quick chat with me and making sure that you're explaining to me how you got the numbers you got. Okay, retakes on this quiz for those people who are still struggling with this skill. Okay, it's going to be on this Friday at 10:15 a.m. in my study hall. And some of you said that the reason you did not take retakes on the quiz last semester was because you were afraid that you might score lower. Well, that's kind of bogus because you know that higher score will be kept. Okay, so if you got 60% on your quiz, original quiz, and you get 50% on your retake, I'm still just going to keep the 60%. However, if you get 60% on your original and then 100% on your second retake, then I am going to take the 100%. Okay, but you must prepare for it. Okay, so you can't and actually the maximum you could get is 90%. Okay, but you must prepare for it, because if you think you can just do better without preparing for it, chances are you're probably going to do worse. Alright, goal for the day: studying quadratic equations and see how quadratic equation models a situation, and recognizing quadratic attributes from a table is what we're going to be covering. So to get you started, we are going to start with the Desmos activity, card number 1. Please pause the video and do that now. So I just have one graph. Okay, so this is my graph and I am matching up everything that goes with this. Now, is this a parabola that is opening up or opening down? So if I was to make the parabola with my arms, am I opening up or am I opening down? I'm opening down. Okay, so I find my opening down and match it up here. Okay, so what else? Where is the vertex? The vertex is the highest or the lowest point. What do we have here? Okay, so we have upside down parabola that is opening down. That means we're going to have maximum point. Okay, so we're going to have has maximum, not minimum, has maximum. And what is the vertex of that? To do that, I can click on the graph and it'll enlarge it for me. So the coordinate is going to be, remember, coordinate is going to be x first and then y. X is -6 and y is +16 because each one is 2 units each. Okay, so +6, x is -6, comma, y is 16. So I am looking for -6, comma 16. So that's this one. What else? Okay, so line of symmetry. Line of symmetry is going to be a vertical line going down like so. Okay, and the line of symmetry always goes through the vertex. And what is the coordinate of the vertex? It's -6, 16. Okay, so what is the x value of this line? X value is -6. Okay, so it's a vertical line, and a lot of people think, oh, it's a vertical line and y-axis is vertical, so it must be y is equal to whatever value. No, it's the x value, because every point on that line has the x coordinate of -6. So x is equal to -6 is my line of symmetry, and that's it. And it says you got it. Let's delve into the lesson. Okay, so what do you remember about x and y intercepts? When you have a linear line, the x-intercept is where the x-axis is crossed by the graph. Y-intercept is where the y-axis is crossed by the graph. That's the y-intercept. So similarly, x-intercept in parabola is precisely that. A point where the graph of the parabola in this case crosses the x-axis. Y-intercept is point where the graph of parabola crosses the y-axis. Okay, so y-axis and y-intercept. Notice the y and y, and x-intercept and x-axis. So looking at the x-intercept first, where does the graph, that's the red curved line, cross the x-axis? It's this point here and a -1. And you represent the x-intercept as a coordinate, -1, 0 and 3, 0. Or you can also represent it as a number, 3 and -1, to represent just the x value. Okay, because the y value is always going to be 0. For x-intercept, the y coordinate is always going to be 0. Okay, so x-intercept, any point on this line, the y value, the vertical position is 0. That is the reason why it's 0 there. Similarly, for y-intercept, where the graph crosses the y-axis is right there, 0, 3, and you write it 0, 3 in parentheses in coordinate form, or you can just give the y value, which is 3. Similar to previously, the x coordinate is always going to be 0 for the y-intercept. So y-intercept will always have the x coordinate 0. Okay, so please pause the video and tell me in private chat, what do you think are the x-intercept for this graph? Okay, so it's that one and that one. So the coordinates are 2, 0 and -5, 0. Or you could write 2 and -5. Okay? Y-intercept, where does the red curved graph cross the y-axis? That's -6. So it's going to be either, you can write -6 or 0, -6. What about this? What are the x-intercepts and y-intercept? X-intercept, we only have one point. Okay, one point where the graph actually just touches and bounces off the x-axis. And you will learn about what sort of graph it has to be to do just precisely that. And what is a coordinate? It's going to be 4, 0, or you just write 4. Or what's the y-intercept? That's going to be 0, 6, or you write +6. Okay, that's a typo. It should be +6, not -6. Okay, so we are going to move on to doing Desmos activity, card number 2 to 21. So please pause the video and see if you can work through them yourself. Don't spend too long on each card. You're basically simulating a basket. Okay, so this one says create the best fit line. Okay, when you had points here, do you remember scatter plots? And you were trying to figure out, okay, what is the line that best fits the points? Okay, so, well, during those times you said, okay, so I can move my black points so that it will approximate the trend. Okay, how does this fit? What do you think? That looks pretty good, but is it really a line? Well, it turns out the lines used to be the only kind of mathematical relationship we needed. Lots of models are linear, but lines are wrong model here. What does your line say will happen to the basketball? What do you think? Okay, the basketball does not keep going up and up and up in that projectile, thrown direction. It actually curves down and eventually it will come down. Okay, so that's what I'll write. So instead we need a relationship called quadratic relationship